hydrolysis occurs via alkyl oxygen fission. Next, the hydrolysis of esters in presence of base or alkali. This reaction is commonly known as saponification reaction. Saponification reaction is an irreversible reaction because here the carboxylate ion is negatively charged and hence very unreactive towards SN2 reaction, and hence very unreactive towards SN reactions. The reaction is CH3COOC2H5 plus NaOH gives CH3COONA plus C2H5OH, sodium acetate. Now the next reaction is hydrolysis of esters in presence of base or alkalis. This reaction is commonly known as saponification reaction. Saponification reaction is an irreversible reaction because here the carboxylate ion is negatively charged and hence very unreactive towards SN reactions. The reaction is CH3COOC2H5 plus NaOH gives CH3COONA sodium acetate plus CH2OH. Since alkalis like sodium or potassium salts of higher fatty acids like stearic acid or palmitic acids etc. are soaps, alkaline hydrolysis of esters is often known as saponification. Now the next reaction in the series of chemical properties of carboxylic esters are ammonolysis, that is splitting by ammonia. Esters like CH3COOC2H5 when reacts with ammonia NH3, they give corresponding acetamide along with the liberation of alcohol. Now the next reaction of esters is alcoholysis, that is splitting by alcohols, or it is also known as trans-esterification. Trans-esterification is catalyzed by acids like H2SO4 or hydrochloric acid HCl or some base. Since both alcohols have nearly similar leaving tendency in the tetrahedral intermediate, the reactant alcohol must be used in order to carry out the reaction in the right direction. Trans-esterification is catalyzed by acids like sulfuric acid or hydrochloric acid or some base. Since both alcohols have nearly similar leaving tendency in the tetrahedral intermediate, an excess of the reactant alcohols must be used in order to carry out the reaction in the right direction. Now the next reaction is acidolysis. Acidolysis means splitting by acids. Esters react with acids like valeric acid, the high fatty acid, to give corresponding esters and carboxylic acid. For example, ethyl acetate CH3COOC2H5 when reacts with valeric acid gives ethyl valerate along with the formation of acetic acid. Next important reaction is the reduction reactions. Reduction reactions may be carried out by means of sodium and alcohol. This reaction is commonly known by its name, Bouvelt-Blanc reduction. Lithium aluminum hydride in ether or hydrogen gas in presence of copper chromide as catalyst at high temperature around 300 degree centigrade temperature under high pressure is also useful to carry out the reduction of ethyl acetate or esters. Ethyl acetate or esters under reduction process gives corresponding alcohols. Esters may be reduced to aldehydes corresponding to the acids by means of diisobutyl aluminum hydride.